Hi again, everyone. Welcome back to our course in college algebra. Dr. Tom McNamara here, continuing to talk about inverse functions. Specifically in this video, we are going to talk about the graphs of inverse functions. And there are two kind of key takeaways that I want you to get out of this video. First, if I give you the graph of a function, you should be able to plot the graph of f inverse using the technique that we'll show you. And two, looking at the graph of a function f, you should be able to tell whether or not it has an inverse. Okay, you should be able to look at the graph and determine that. We'll talk about how to make that test, how to do that. So let's get right into things and look at an example graph of a function, and we'll plot the graph of f inverse. Given y equals f of x, this graph plot y equals f inverse of x. So I'm going to quickly but carefully draw the graph of a function. Take care to make sure my tick marks are nice, evenly spaced. So let's say we got, I don't know, maybe this point here, this point, okay, so we got this part of the graph is looking like that. Maybe over here we go like, maybe like that. Put in 2, we get 2, and let's say we put in 3, we get 4. Okay, so this is the graph of my function, y equals f of x. Now notice I am not giving you the formula for the function. Okay, I'm just telling you this is the graph, this is the function. Now, we got to think back and remember what it means for a point to be on the graph of a function. So I'm going to make a little catalog of the points that I have on this graph. So I can see I've got -3, -1. I can see I've got -2, 0. I can see I've got -1, 1, 2, 2, and this is 3, 4. Okay, now remember, points on the graph are input-output pairs. If I use 3 as the input, I get 4 as the output. That's what this is telling me. And let's think about what inverse functions do, right? So a function takes an input, gives you an output. The inverse function goes backwards. It takes the output and tells you what input you need to use. So the inputs to the inverse function are the outputs from the original function, and it goes backwards. So here's what we do. Every point on the graph of f is going to give us a corresponding point on the graph of f inverse. So this tells us for the function f, -3 goes in, gives us an output of -1. The inverse function is going to go backwards. The inverse function is going to take -1 and give us the output, -3. This says the original function takes -2, gives us 0. The inverse function will take 0 and give us -2. And we'll switch all the corresponding points. Okay, now we plot those. So -1, -3, which is down here. -1, -3, 0, -2. 1, -1, 2, 2, notice that was on the original and it's also on the inverse. That was because the two coordinates were identical, so when I swapped them I just got back the same thing. But here they were not identical. 3, 4 becomes 4, 3, the point on f inverse, which is over here. Okay, now we'll just connect the corresponding anchor points there. And we got this. That's y equals f inverse of x. All right, so a very straightforward process to take the graph of a function and plot the graph of f inverse. And if you look back at our last video, what we were doing was finding a formula for the inverse. And the first step in that process of finding the formula for f inverse was to switch x and y. Okay, so it's completely consistent with what we're doing here. You want to find the graph of f inverse, you switch x and y, and that's all you have to do. Okay, so having the graph is easier than having the function's formula. Okay. There's another thing I want to mention in this video, and that is how to look at a function's graph and determine whether or not your function even has an inverse. So let's do a little quick note here. Some functions do not have inverses. Okay, some functions do not have inverses. Let me give you a quick example. If f of x equals absolute value of x plus 3, and f of x equals 4, what is x? Okay, so in other words, I'm starting with the output, I want to work backwards. And that's the parlance or the purpose of an inverse function. Okay, an inverse function is supposed to start with the output and give us the input that produced such an output. Now you might say, okay, well that's an easy one, Dr. Mack. You got 4 out, you put in 1. Okay, and yes, you could have put in 1, but that's not what I did. I didn't use x equals 1. I put in -7 and got 4. Right? Do the calculation. -7 plus 3 is -4. Then the rule says take the absolute value, and the absolute value of -4 is 4. So this input also produces the output 4. So there's no way to work backwards and say for sure which one I used. Okay? And if we have this kind of ambiguity, then the function does not have an inverse. Now let's look graphically at what's happening here. Okay, we know what the graph of this function is going to look like. Okay, we can see this function involves the absolute value. We know it's going to be v-shaped. You replaced x with x plus 3, that shifts you 3 units left. So there's the point of our v at -3, 0. And basically what we're seeing here is that the horizontal line y equals 4 intersects this graph at 2 places. -7, 4 is on the graph, and 1, 4 is on the graph. So we have a horizontal line that intersects this graph in 2 places. In fact, we have tons of horizontal lines that will intersect this graph in 2 places. So this thing fails the horizontal line test. Okay? If you can draw a horizontal line that intersects your graph more than once, then you fail the horizontal line test. And if your graph fails the horizontal line test, your function has no inverse. Okay, this function does not have an inverse. And we can tell there are going to be tons of functions that will fail the horizontal line test. Pretty much any absolute value function is going to have a v-shaped graph like this. So it's going to fail the horizontal line test and will not have an inverse. A quadratic function, that would be a U-shaped graph. You remember that from the earlier videos? a U-shaped graph called a parabola. That will fail the horizontal line test. The only way to pass the horizontal line test is if every horizontal line intersects the graph at most once. If any horizontal line crosses more than once, then you fail the test and you don't have an inverse. So lots of useful stuff about inverse functions from the graph. Given the graph, you can look at it and tell whether or not the function has an inverse. If it does have an inverse, we had that procedure that we talked about at the beginning to plot the graph of f inverse. So the graph of a function, once again, extraordinarily useful, and that's why it's really important that we can plot accurate graphs in a course like this.